Alright, welcome back to another video on my channel, math_exe. And today we're going to look at some problems involving like average speed. And these ones may be a bit challenging for you, but you may try them on your own. Like you may pause the video if you want to try it first. So anyways, without any further ado, here's the first question. Alright, for the first question, is always best to draw a diagram to kind of like picture the question into your mind. So let's just draw a diagram right here, and it says this is city A and this is city B, and the distances between these two is 330 kilometers. And I'll just draw some separate diagrams for you, just in case you might get confused. Alright, so it says a car departed from city A at 9 o'clock. So let's see. And it's traveling to city B at an average speed of 60 kilometers per hour. So let's just write that. And it's also known that a truck departed from city B at 9:30 and is traveling to city A at an average speed of 40 kilometers per hour. So from this point, it is 40 kilometers per hour. Alright, I'll just fix the 4 real quick. There we go. Alright, so it says at what time will they meet each other and how far will the meeting point be from city B? So let's assume that it will meet around like here. They will meet like here, and then we need to find at what time will they reach this point and how far will this point be from city B. Now an easy way to do it is to look for some patterns for this question. So what I would like to do is, I'll just erase this tool right here. And let's see the condition at 9:30. So for the car, which is already departing from city A, and in fact has traveled a distance, and that distance can be given by distance is speed times time. This is generalized from the speed equals distance over time formula. You just multiply t by both sides, so yeah. And what's the speed? It is 60 kilometers per hour. What's the time? Well, we can just subtract the time since we want to find the conditions at 9:30. So 9:30 minus the initial departing time, which is 9 o'clock, which is just 30 minutes. However, we're not comfortable to express this in minutes because we're working in kilometers per hour. So that's no problem because we can just convert this 30 minutes into hours, which is just half an hour, and this will become 30 kilometers. And notice that 9:30 is the time where car B will start to depart, so it's already starting right here. Well, car A has already traveled a distance of 30 kilometers per hour. 30 kilometers, sorry. So just write this as red. Let's say it's around here. This is a condition at 9:30. And what I would like to do again is notice that the remaining distance that the car has to travel again is just 330 minus 30, which is this 300 kilometers. And at this point, what I would like to do is um, let's just see the conditions at 10:30. So I have 10:30 right here. Notice that this is an hour after this condition. So car A travels a certain distance, car B also travels a certain distance. And what are those distances? Well, you can just multiply the speed and the time. The time is given 1 hour. So for the distance traveled by car A will be 60 kilometers. And the distance traveled by the truck will be 40 kilometers. And you may already know we can just draw a line right here and notice the remaining distance. Since this is 30 kilometers and is now shrinked down, so we can just subtract 300 by 60 and 40, which will leave us with this distance being 200 kilometers. And we really don't need this information, because we're going to look at the conditions 1 hour after this. So again, repeating the same process. After traveling 1 hour, this will travel 60 kilometers, and this will travel yet again 40 kilometers. And note that the diagram is not to scale, so yeah, just note that. So we can draw yet another line like so. So the remaining distance will be just 200 kilometers minus 60 minus 40, which is just 100 kilometers. And you may or may not have seen the pattern yet. That is, every time you go fast forward an hour, the distance shrinks by the sum of their speeds, which is 60 plus 40, which is 100. And actually, there is a formula for this type of question. So the time needed for them both to meet up is the distance between them both, which is not in this case not 330, which is what I will explain a bit later. But however, it is 300 kilometers. And then you can just divide all of this by the sum of their speeds, which is 60 kilometers per hour plus 40 kilometers per hour. And you may already guessed, this will become 100 kilometers per hour, and then the final result will be 3 hours. Now you may be asking why the total distance isn't 330 hours. Well, this formula only works if both vehicles or both objects are in motion, which means they are both starting to move. So if we take 330 kilometers, notice that A already started to move. However, B does not, because its departing time is 30 minutes after that. So yeah, and notice this 300 kilometers is the distance between the car and the truck at 9:30, which is the point where those both vehicles start to move or start in motion. So we can just find the time of the meeting point by just adding that 9:30 by the 3 hours we have. So which is just 12:30. Okay, and For the next thing, we need to find how far the meeting point is from city B. And you may be already guessing that it will be 120 kilometers because if you have found the pattern already, the meeting point will be around right here, which is 3 hours after 9:30, and we already counted at 9:30 is the point where vehicle B started to depart and move. So I'll just note this distance right here as 40 kilometers, and then we can just multiply them by 3. So we have 40 kilometers times 3. 40 kilometers times 3, which is 120 kilometers. And I will just recall what we did before in case you're a bit confused. So we first look at the condition of both vehicles when at 9:30. So in that case, the car has traveled 30 kilometers and car B hasn't started to move yet. And we're going to look at this point at 9:30 because we're going to use our formula. And actually I'm going to generalize it right here. So the time taken for any two certain objects to meet each other in like a given case, like in this question, is the distance between those objects and over plus or minus the speed of the first object. I'll just denote this as S of A, and I'll just denote this distance as DAB, which denotes as the distance between object A and object B, and then we have plus or minus S of B. And there's a thing called velocity, which you will further learn in physics, which is just similar to speed, but you need to consider the direction of it. However, if I explain about velocity right here, you might get even more confused, so I won't do any of that. However, you can determine whether these speeds have to be positive or negative by drawing a diagram and look for patterns like I did before. So you may draw a diagram in a piece of paper and then see what results you have using this trick. And yes, it might be very confusing since this kind of question is very difficult. However, if you practice a lot, you might be very good at it. So yeah. So that's all I have to say for this question. Let's get into a similar type question with this question right here. Alright, for the second question, I have drawn a diagram as you can see right here. So it says that Andy and Bob are standing on opposite sides on a circular track with radius 7 meters. And with that given information, we can find the diameter, the circumference of this circular track. So given our formula for our circumference, so circumference will be 2 pi r. And we can just take pi as 22/7 because we're dealing with a multiple of 7. So we're comfortable with that. So 2 times 22/7 multiplied by 7 meters. Notice the 7 and 7 will cancel, leaving us with 44 meters. And notice, but they were standing on opposite sides. So the distance between Andy and Bob in the circular track, like here, as you can see, this is the half of the circumference. So this will be half of 44 meters, which is just 22 meters. So I can just erase this real quick, and yeah, there you go. And they both started jogging in the same time with speeds 5 meters per second and 3 meters per second respectively, both in the clockwise direction. And I'll just write this for you. So Andy will travel right here in 5 meters per second. Bob will travel in this direction in the speed of 3 meters per second. And the question is asking how long will they meet each other for the first time. And what that means is after they both started jogging, how long after that will they meet for the first time. So yeah, we can just do a pattern right here. So let's just look at what happens a second after they both start jogging. So after 1 second, Andy will travel 5 meters because this is the distance traveled in a second with a speed of 5 meters per second. Doing the same right here, we get Bob travels at 3 meters. So we need to find what's the distance now between Andy and Bob if they are in this point, at this point. Well, as you can see, I'll just undo this for you. If Bob hasn't moved yet, we can just suppose this right here. The distance between Andy and Bob right here is 17 meters. And then after Bob moved, the distance increases by 3 meters because Bob is moving away from Andy. So we'll leave. So the total distance between Andy and Bob after 1 second is 20 meters. And then you can just do this repeatedly and notice a pattern that the total distance between Andy and Bob decreases by 2 meters every 1 second. So we can just rewrite this. Total distance decreases by 2 meters every 1 second, or we can just write 2 meters per second, or just write every second, so you won't get confused with speed and distance. Okay, so with this information we can just calculate our time. So our time is the total distance between Andy and Bob, and we must ensure this total distance occurs when they both are starting to move or to be in motion, which is in particular the case because they both started jogging in the same time as the question said. So we're good to go. So 22 meters, which is just the distance between Andy and Bob, and then the decrease of the total distance is just 2 meters per second, and leaving us with a time of 11 seconds needed for them to meet each other for the first time. Alright, I would probably do one last example of this type of question. Alright, for the last question, again we're going to draw a diagram. So we have car A, so just write that here, and then we also have car B. And car A departed from town A at 6, and it's traveling at an average speed of 80 kilometers per hour. So write this. And car B departed an hour later I'll just notice right here, and then it's traveling at an average speed of 90 kilometers per hour. And then what time will car B bypass car A? Or in other words, what time will car B will take the lead over car A? So yeah. So note this is let's just look at a condition where at let's say at 7, because 7 is where car B will start to depart. So note that car A will already travel 80 kilometers, because that is the distance covered by car A in a span of 1 hour. So yeah, you can just multiply the time and the speed to get this. So yeah, so B hasn't moved yet, so yeah, but it will eventually start to move. So keep an eye with this distance right here, and then look for a pattern with involving this number right there. So first, we're going to look at a condition of, this is before 7 o'clock. Now we're going to look at a condition of 8 o'clock, which is 1 hour after. So car A again will travel 80 kilometers. However, car B will start to travel 90 kilometers, and that is the distance covered by car B in a span of 1 hour. And what's the distance between car A and car B right now? Before in 7, the distance between car A and car B is 80 kilometers. So it's pretty simple to notice that the distance between the car A and car B at 8 o'clock is 70 kilometers. So yeah, and then we can just do the same at 9 o'clock right here. I'll just erase this real quick, and yeah, car A will travel 80 kilometers, car B will travel yet another 90 kilometers, and therefore the distance reduces to it will be 60 kilometers, and it's not hard to notice it. And we can just already notice the pattern right here. Notice that the distance between A and B decreases by 10 kilometers every hour. So we can just write this down. Between A and B, this decreases by 10 kilometers every second. Every hour. So yeah, and with this information we can just now do the formula. With T is equal to the total distance between the two objects, which is, we're going to take 80 kilometers right here, because notice that this is the distance between car A and car B when they will both move or in motion. So we're good to go with this. So next we have our decrease in our distance, which is 10 kilometers, and I would add per hour right here, and this will be equal to a total answer, an answer of 8 hours. However, that's not so it says what time. So yeah, so it's pretty easy to do this. We need to consider our time for our observation. and the time we chosen first is 7 hours, and this is where both cars will start to move or in motion. So yeah, so we could just sum the time by our 8 hours right here. So we have 7 plus 8 hours, which is 15, and this is the final answer. And thank you guys for watching this video, although it might be seemingly difficult at first, but you may do some practice on your own, which is why I'm going to give you a homework for you to do, and you may post your answers in the comments below. So yeah, thank you guys for watching, and please subscribe for more, and I'll see you guys in the next video. And here's the question for the homework.